Grade 11s, we're going to look at some review questions today. It's been a very long unit and we've covered a lot of related but strange things. So let's have a look, first of all, at exponential functions. We're going to graph, state the domain, range, x-intercepts, y-intercept, equation of the asymptote, exponential growth or decay. So we're not going to do a fancy graph. We're going to do more like a sketch. For y equals 6 to the x, it is growth because it has a base greater than 1. If I have an exponential equation without any transformations, then the y-intercept is 1. I also know it doesn't touch the x-axis, so there aren't any x-intercepts. The range would be greater than or equal to 0. Y is greater than or equal to 0 and a real number. The domain is any real number goes. I am looking for the equation of the asymptote. The asymptote is that line that it approaches and never gets to. So our asymptote is y equals 0. Roughly, a graph for this. Y equals 6 to the x. I have a y-intercept of 1. As I go to the left, I get closer and closer to the x-axis. As I increase quite sharply, 6 to the x, so one value, for instance, would be when x is 1, I have the 0.16. So my growth is very sharp. What is the difference between that one and number b, which is 6 to the minus x? 6 to the minus x is the same as a flip, so it would be 1/6 to the x. I know that's exponential decay, and that doesn't have any transformation, so it will have a y-intercept of 1, but it's decaying and getting closer to that asymptote going that way, and very steeply just opposite to the other one. So what will have changed? The y-intercept, the asymptote will be the same. The y-intercept will be the same. It is, however, exponential decay, getting smaller. There are no x-intercepts. The range would be the same, and the domain would be all real numbers. This third one is y equals 0.97 times 1.01 to the x. This would be like starting with 97 cents and growing with 1% growth rate. What would our various things be? As a rough graph, our initial value is 0.97, so our y-intercept would be 0.97. It is exponential growth, so we would be growing like that. There will be no x-intercepts. The domain. Well, it doesn't say that this is a word problem, so we're going to assume that it could be any real number. And the range would be greater than or equal to 0. We are asked for the asymptote. It's the same. The asymptote is that line y equals 0 because it hasn't moved up or down. Y equals 3 times 0.87 to the x. So we start with something with a value of 3. So that will be our y-intercept. This is going to be exponential decay because its rate of growth is less than 1. So it's going to do that. The asymptote will still be y equals 0. The domain will still be all real numbers. The range greater than or equal to 0. Those two things are related, the asymptote and the range. What else are we asked for? The y-intercept is 3. X-intercepts there aren't. I think that's it. Y equals a half to the x. The initial value, or the y-intercept, is 1 for a regular exponential equation. This is a base less than 1, so it's going to be exponential decay. It's going to half as we go to the right. Y-intercept is 1. No x-intercepts. Domain is the same. Range is the same. Asymptotes are the same. Oh dear. Y equals log base 2 of x. This to me is easier to start with a graph. I remember that it's the opposite of exponential growth. It has an x-intercept of 1 instead of a y-intercept of 1. Grows as such, and so on. Things are a little different for this one. This one appears to have an asymptote of the y-axis, which is x equals 0. The domain will be x has to be greater than or equal to 0. And it will have a range of any real number. There is no y-intercept. There is an x-intercept. It's 1. And I think we've covered it all for that one. Question number 2, using a graphing calculator, find the point of intersection. So if we're finding the point of intersection of this and this, we are really trying to solve the problem, when is 150 equal to 10 times 1.8 to the x? So with our graphing calculator. All right, first lesson is don't deface the calculator. Second one, we want to find the point of intersection. So my first line, sorry, I don't need that. First line will be the line 150. And I'm going to pair that with the curve 10 times 1.8 to the power of x and see where they intersect. Let's see if we can even see it first. Not a chance. Because I know that line is at 150 and I don't have y values sufficient to see that. So let's change our windows so that I have y values beyond 150, sorry. Let's go 200. Let's see what happens. There's my line. And here's my curve. Yes, I can see the point of intersection. Second function, calc, gets you to all the things the calculator will do for you with graphing. Number 5 is your option. So you've got to tell it the curve. So right now it's on the first curve, which is the line. Enter. It jumps to the second curve. You can see it down at the bottom. There it is. And that's the other one that you want. So hit enter. Enter again. And it will give you the point of intersection. 4.6 4.6 comma 150. So the answer to this problem is x equals 4.6. We're going to solve these equations, and we have a bunch of different ways that we can use. The first one we're going to use, we're going to solve by changing to the same base. I've got 4 to the minus x and 8 to the x plus 3. I could rewrite both of those with a base of 2. So 4 I'm going to replace with 2 squared. 2 squared to the minus x equals, I can replace my 8 as 2 cubed to the x plus 3. Rules of powers. I have power of a power. I multiply the exponent. So I have 2 to the negative 2x equals 2 to the 3x plus 9. I'm using basically the distributive law. If I have two powers that are equal and the bases are the same, therefore the exponents would have to be the same. then minus 2x is equal to 3x plus 9 to make that equation true. I am going to subtract 3x from both sides. I have an answer of x equals minus 9 over 5. B, 3 to the x equals 5. We're going to solve this one by guess and check and see how far we get. I know my powers of 3. 3 to the 0 is 1. 3 squared is 9. 3 to the 0 is 1. So I know all that, and I want to have where 3 to the x is 5. So it's in between 1 and 2. So let's try x equals 1.5. 3 to the 1.5 I have to do in my calculator, and I'm going to do it to 2 decimal places. 3 is 3 to the 1.5 is approximately 5.2. So just a little bit big. So I'm going to try 3 to the 1.4. 3 is 4.66. So it's in between. We want 2 decimal places anyway, so let's try 1.45. 4.92, very close. Little too small, so 3 to the 1.47. Is this the most efficient method? Absolutely not. 3 to the 1.47 and 3 to the 1.46. It's right in between the two. So 3 to the 1.46, which is 4.97, which is very close. 0.5 to the x equals 3 to the x plus 3. We're going to use a graphing calculator for that one. So I want to find out where 0.5 to the x meets with 3 to the x plus 3. So in my graphing calculator, I'm going to have my first equation as that exponential curve and the second equation as that exponential curve and find their points of intersection. So it's clear. The first one is 0.5 to the power of x. The second curve is 3 to the, and I would use brackets here, x plus 3. Our windows got all wonky the last time, so let's put them back to where they belong and see if we can see our curves. There's the first one, and there's the second one, and we can see the point of intersection there. So our calculator second function, calc intersection, is number 5. First curve and second curve, and guess, is negative 1.8 comma 3.6. 1.8, 3.6. If I'm trying to solve this, I want to know what is x. X equals, by looking at the point of intersection, negative 1.8. If 4 to the x equals 7, we could solve that in any of the above ways, or we could use logarithms. So if I take the log of both sides, log of 4 to the x equals log 7. I know from my rules that I can bring that exponent to the front. X times log of 4 equals log of 7. I'm going to divide both sides by log 4. And typing that in my calculator, it's approximately 1.4. The last one, 5 to the 2x minus 5 equals 18. We can solve in any one of the above ways. I'm going to choose, and my favorite is logarithms. I'm going to take the log of both sides. With logs, I can bring down the exponent. I put it in brackets just to keep it clear. 2x minus 5 times log 5 equals log 18. If I divide both sides by log 5, it's just a number. And I'll have 2x minus 5 equals that number. Let's type it in our calculators. Log 18 divided by log 5 is 1.796. 2x minus 5. So if I add 5 to both sides, I have 6.7956. And I'm going to divide both sides by 2. 3.397. 8 actually. Round, there we go. There's my. Right, a tire with puncture loses pressure at a rate of 4% per minute. So first of all, it's losing, and then it's that rate. If the tire's pressure is 300 kilopascals to begin with, what is its pressure after 1 minute? So our equations all look similar. I want to know pressure. I start with initial pressure times my rate to the time. So I want to know its pressure. It started with 300. My rate. My rate is always what I keep. And I am losing 4% per minute. So I am keeping 96%. And it is going down at 3% a minute. So x is in minutes. Should define my variables. I want to know after 1 minute. So in 1 minute, I have 300 times 0.96 to the 1. I will be left with 288 kilopascals. In 2 minutes, my pressure will be 300 times 0.96 squared. $276.5. Use a graphing calculator to determine when the tire's pressure will be 200. So I want to know when my equation is equal to 200. So I have 200 equal 0.96 to the x. I want to know the time. How long will it take? So I'm going to use a graphing calculator. You can do this in 2 ways. I can type in my equation 300 times 0.96 to the x and just trace along that equation to see when it becomes equal to 200. Or I can have one equation equal to 200 and a second equation equal to 300 times 0.96 to the x and see their point of intersection. It's a little faster and maybe a little easier, so that's how I'm going to do it this time. I'm going to clear those two from last time. When is the line 200 equal to 300.96? Oops. To the x. I'm going to have to change my y values for certain because that line is well above my regular default. So I'm going to change that to 300. See what happens. There's my line 200. There's my graph for 300 and decaying. I can just barely see it. I need a little bit more x value. I also wonder about that equation. To the power of x. No, it's good. There's the line. There is my exponential curve with its slight decay of 2%. Where do they meet? Point of intersection, second function calc, number 5. There's the first one. It's the line. Jumps to the curve. Enter again. Point of intersection is 9.9 comma 200. So the solution is 200. Oh, sorry, 9.9. Silly. You have to be able to read the data. So in 10 minutes, you're going to be down to 200 kilopascals. That doesn't sound good. Some powers to look at. I don't know why students don't like these. I really don't. X to the 5th y cubed times x squared y to the 7th. We keep our bases and add the exponents is our rule for multiplication. I have x's, so keep the base, add the exponents, I get x to the 7th. I also have y's, keep the base, add the exponents, done. B, I have 2x squared y squared to the 3. That means everything in that bracket is cubed. It means 2x squared y squared times 2x squared y squared times 2x squared y squared. But I have 2 cubed, x squared cubed, which I multiply the exponents, y squared cubed, which becomes y to the 6th. So best answer would be 8 x to the 6th, y to the 6th. The next one, I have power of a power, and I have multiplication, and I have division. So I'm going to do the power of a power first. I have a squared b to the 4th times a cubed b squared. A to the 4th squared is my power of a power, and I multiply exponents. So I have multiplication and I have division. I'm going to do the multiplication first. I'm going to multiply the tops over multiply the bottoms. That's my rules for fractions. So I have a squared b to the 4th times a to the 8th. I have a's that have a common base. My rule for multiplication is add the exponents. I don't have any other b's, so I have b to the 4th. On the bottom, I have a cubed. Then I have b squared times b squared with same base. So I have b to the 4th because I add the exponents. Now I have division. Keeping the a's and b's separately, I have a to the 10th divided by a cubed, subtract the exponents, a to the 7th. B to the 4th divided by b to the 4th. Well, it's the same thing, so you would just cross them off. Or remember that you keep the base, subtract the exponents, b to the 0. Anything to the 0 is 1. So my final answer is a to the 7th. 2 to the n plus 2 times 4 to the n plus 1 over 8 to the n is a little tricky because we don't have any rules for things unless they have the same base. So I'm going to convert all of these to have the same base. I'm going to use base 2. I can replace my 4 with a 2 squared. Notice that I leave it in brackets. It avoids some error. On the bottom, I can replace the 8 with 2 cubed. Now I have the same base everywhere, and I can use all my rules of powers. I am going to do the 2 power of a powers. The first power here, I can just leave it alone. But 2 squared to the n plus 1 is power of a power. And my rule is keep the base, multiply the exponents. Same on the bottom. I have power of a power. I keep the base, multiply the exponents. On the numerator, I have multiplication. My rule is keep the base, add the exponents. So I have 3n plus 4. On the bottom, 2 to the 3n. Now I have division. My rule for division is keep the base, subtract the exponents. 3 to the n, subtract 3 to the n is 0. So I'm just left with the number 4. 2 to the 4 is 16. I am done. Evaluate log base 3 of 1 over 81. Just recalling that what I am looking for is 3 to the what equals 1 over 81. 3 to the, well, it's going to have to be a negative to get a flip. And 3 to the 4th is 81. So if x were negative 4, 3 to the negative 4 is flip 1 over 81. Log base 5 of 32 to the 8. Well, something happened there. To the 8. My rule of logs is that if I have a power, I can bring the exponent down. So that would be 8 times log base 5 of 32. Log base 5 of 32 is horrible. Log base 5 of 32, I just don't know. But I do know that I can get it from log of 32 divided by log of 5. 8 times some horrible number. Let's find it. 2.15 approximately times 8. 17.2. Question number 7. Change what equals log base 8 of 32 into exponential form. If y equals, that means that 8 to the y equals 32, which is what I do every time I see a log question anyway. Going the other way, 125 equals 5 cubed. I'm going to change it into a log so that the relationship is the same, it just looks very different. So the base is 5, just like in the exponent. Log base 5 of 125 equals 3. That would be great to be able to go back and forth between those two forms. Number 8, solve for x. 10 times 3 to the x equals 270. I would divide both sides by 10. And then I have a power of 3 to the x equals 27. That one I know because 3 cubed is 27. So x must be 3. Log base 5 of decimal 04 equals x. There are two ways to solve this one. The first way is log decimal 04 divided by log 5. Log of decimal 04 divided by log of 5 is negative 2. But if you weren't sure about that way, you could always translate it to an exponential function. So if log base 5 of decimal 04 is x, that means that 5 to the x is equal to decimal 04. 4 out of 100 is the same as 1/25. So I know my x value would be negative 2. Log base 2 of x equals 5. Well, another form for that one would be 2 to the 5th equals x. X must be 32. 3 times 4 to the x plus 1 equals 120. The first thing I would do would be to divide by 3. We can solve that many different ways. We can look for a point of intersection. We can guess and check. We can solve by graphing. No, thank you. We can do logs of both sides. Totally up to you. I'm going to do logs. If I do log of both sides, I know that my exponent can be brought down on the left side so that I have x plus 1 times log 4. I'm going to divide both sides by log 4. I'll be left with x plus 1 is approximately equal to 2.66, and subtract 1 from both sides, approximately 1.66. So the Chapter 4 review handout is to work on before a test.